Hello, everyone. What I want to do now is go over chapter 6 in Broverman's book. And in particular, we're going to talk about the term structure of interest rates. We're going to talk about yield curves. We're going to talk about spot rates and talk about forward rates. Very important topics in exam FM. And after these topics, the only topics we need to cover are duration, convexity, and immunization, which I hope to have videos on also. And so with those two portions of, or those two collections of topics and the videos correspond to them, we will have the entire exam FM covered. All right, so I want to go back to something I talked about if you're in my 301 class. Very briefly, I talked about, and very, very briefly, I talked about, and that's the reason why the curiosity here that we have a very small interest rate for a 2-year treasury note, and we have a very relatively bigger yield rate for a 30-year bond. So one little practical point of clarification: if you ever hear the term treasury note, that's just a short-term bond. Bonds are usually reserved for long-term bonds. And this is from the U.S. Treasury, the Fed. Okay. And so the idea was that investors, generally speaking, are willing to take a very small yield for a short-term investment because you're only locking up money for 2 years. So who cares? You're making some money. And if you're buying millions of dollars of this, if you're buying millions of dollars of this bond, then, you're making still tens of thousands of dollars in a very short amount of time. So it's very safe. You only have money locked up for 2 years. On the other hand, if you're locking up money for 30 years, that's a hell of a long time. And within that range of 30 years, you're probably going to find some good investments. I mean, things go up, ebb and flow. Stock market goes up and down. But in general, like 30 years is a long time. You're going to find good investments within that 30 years, even if you can't find them now. So to lock up money for 30 years, investors demand a large yield rate. Okay. Okay. So in general, we have this concept here called the term structure of interest rates. I'll move this in a second. I'll make this a little smaller for the time being. I apologize for the crappy camera and lighting here. So the term structure of interest rates in general is a difference in interest rates for different maturity periods, meaning you have money invested for different amount of times. So that's what we mean by different maturity periods. Okay, so when you buy a 30-year bond, you have money locked in for 30 years. You wait, you don't get your face value back for 30 years versus 2 years, you get your face value back in 2 years. You do get your coupons every 6 months regardless, but anyway. Okay. So particularly for bonds that the U.S. government issues, a curve or table of these different interest rates corresponding to different maturity periods, and these are yield rates, of course, for bonds. A curve of this or a table is called a yield curve. Okay, so an example in the book is the following yield curve. So for a 3-year bond, don't know if that would correspond to a treasury note or a bond, but doesn't matter. It's about 0.5% is the yield rate. On the other hand, for a 30-year bond, it's more like just roughly, if this is 3%, it's about 2.75%. Okay? And this kind of picture, this increasing kind of like, this increasing kind of graph is a normal yield curve. Again, the idea is that investors are willing to accept small yield rates for short periods of time and demand larger yield rates for much longer periods of time for the reasons I stated earlier. Okay. Okay, well, this isn't always the case. In good times, this is usually the case, and this is what we all hope for. But in real life, what happens a lot is or not a lot, but what happens is you sometimes have shorter term yield rates become larger than longer term yield rates, excuse me. And when this happens, this is called the yield curve flattening or the yield curve inversion. And often you get this even for a time period. So you might have something like this here for a large period of time, but you kind of have like a little kind of inversion, you could say like between 15 and 20 years or something like that. It's just a little, and I'll show you an example of that. That's actually what happens in practice. But sometimes you have like a little kind of dip in otherwise increasing function. Okay. And so there's a lot that goes into the yield curve. And let me also kind of throw in a bit of practicality here. For a yield curve, the Fed actually, practically speaking, sets yield rates for short-term bonds, I think up to like 2 or 3 years. And then it's largely the market that sets the yield rates for longer-term bonds. Okay, so that's generally, roughly speaking, how a yield curve is formed. I could probably spend a whole semester on exactly what goes into yield curves, the U.S. banking system, and there probably is 300-400 level courses here at UAlbany that literally spend an entire semester on the U.S. banking system and the Fed and yield curves. I'm not going to get too much into that. But why might this happen? There's a lot of reasons. Don't want to get too much into it, but 2 simple practical reasons is 1, pessimism. If you're really pessimistic for the future, then you might be very happy to lock in a 30-year investment with an otherwise crappy interest rate. Okay. So yeah, you might be very happy with absolutely minuscule yield rate for 30 whole years because, like, you found something that's at least going to guarantee you're going to make money for 30 years. On the other hand, because you might want to lock in money at a certain rate while you can, you might demand a high yield rate for a very short period of time. Okay. Or if you think yield rates might be going lower in the future, you want to lock in a nice long-term, even if it's not nice, you want to lock in a long-term yield rate right now because you think they might be going down. Okay? And you might think they might be going down for a while. So you want to lock in a long-term yield rate right now so that it maybe doesn't go any further. And so you have to be enticed to put your money into something short-term. Okay? All right, so as I said, in practice, yield curves kind of, sometimes they invert and they just in general look weird. So this is November 10th, 2022. A cool little website, USTreasuryYieldCurve.com. I haven't checked what today's yield curve looks like. It's November 15th, 2022. This is cool because the Fed website actually just has a chart for a yield curve. It's kind of silly, but it should have a curve. All right, so enough of that. That's basically the idea of yield curves and why people care. And as I mentioned in lecture, and I want to emphasize, for U.S. government bonds, trillions of these are bought. Countries all over the world invest in U.S. bonds because, as I mentioned, despite all the problems the U.S. government is going through, the U.S. government is not going to collapse anytime soon. Most people don't. Most countries, looking to invest, really think the U.S. government is a very safe investment. And that's why we're very interested in, a graph of yield rates for certain, different maturity times. Yeah, that's why we're interested in a graph of such yield rates for different maturity times. Okay. All right. So in general, we can apply this concept. There's nothing special about the yield curve and bonds. So applying this concept in general gives us a spot rate. So a spot rate is the effective annual interest rate, RT, of money invested now for a period of T years. And actually, before I do more about this, I just want to, I won't play this. I'll play this in lecture if you see it. I don't know if you're in my class, but this is actually a really nice video on the yield curve and how actually the yield curve often predicts recession. Even just the first 5 minutes or first 3 minutes of this video is really nice.
Traders often look at the bond market for clues on how.
So it's a really nice discussion of what the yield curve is. So this is, I just inputted how the yield curve predicted every recession for past 50 years into YouTube, and you'll get this nice CNBC video. Okay, but yeah, you can do that on your own, watch this video, so I'm not going to waste time doing that. And this video is on Blackboard if you're in my course. All right, so right, what is a spot rate? The spot rate is an effective annual interest rate, RT, of money invested now and invested for a period of T years. So this RT is exam FM notation. And in particular, so yeah, if we go to, this is a database of questions from the Society of Actuaries of exam FM sample questions. My understanding is for some really stupid reason, an obnoxious reason, I don't understand why, but these are generally easier than exam FM problems. No idea why would you put a list of sample questions, make them easier than the exam to make the exam seem, to make the exam seem easier than it really is. But anyway, that's second, yeah, so I'm using this notation here, RT, for spot rate, because that's the notation exam FM uses. So some other notation that particularly the book uses, and by book, I mean Broverman, Mathematics of Investment and Credits, whiteboard. So this notation I use, the book uses S0 of T, S for spot rate. 0 means just we're investing money now and then letting it sit for T years. T is just T. So yeah, if you see this here, that's spot rate, S for spot. Not sure what R represents here, but all right. So anyway, back. Go back to the screen here. Okay, give me a second. Okay, sorry about that. All right, so the basic formula is as follows, and this should make perfect sense. So the present value of K due in T years, given a spot rate RT, is K over RT to the T. Okay, and the idea is that if we take this value, we invest it for T years, we're getting an interest rate of RT for that whole T years. So the growth corresponding to that investment rate is 1 plus RT, compound it, and that's an annual rate. So compound it for T years, we get back K. Right? And also the accumulated value after T years is 1 plus RT T. Again, we're earning a per year rate of RT for T years. So each year's growth rate is 1 plus RT per year, compounded T years, and this is our accumulated value. Okay, so an easy example, find the present value of an annuity. Find the present value of an annuity paying $2 at the end of the first 3 years and $5 at the end of the next 3 years, given the following term structure of interest rates. Okay, so this is often how we're given information. We have terms in years. We're given years and given t-values, and then we're given the spot rate. Okay, so yeah, let me go through this. It might be a little weird, but yeah, let me go through this. Do this nice and slowly on the whiteboard. All right, so let me erase this. Okay, so here's the time diagram. So you don't really need the time diagram, but I guess I think maybe drawing the time diagram makes this explanation a little easier because it is a bit strange. But so it's $2 for at the end of the first 3 years, and then $5 at the end of the next 3 years. So the idea is we pay for this annuity. So think about it in this following way. We're investing money to get all these back at the end of the first year, second year, third year, fourth year, fifth year, and sixth year. So for the first year, it's like I invest a certain amount of money and I'm getting this back. So it's like that money earns 1 year of interest. Okay. So for this 1 year, I'm going to use the 1 year spot rate. So it's going to be 2 over 1.027. So in other words, I'm investing this, and at the end of the first year, I'm getting $2 back because I'm earning 1.027 per year for the first year. Now, for the second year, I'm investing. I'm going to use the 2 year spot rate. So it's 2.9%, so 1.029 squared. Okay. So the logic here is I'm taking this money, investing it for 2 years at this 2 year interest rate per year of 1.029. So after 2 years, I get $2 back. That's the logic here. Et cetera, et cetera. So I'm going to use the 3 year spot rate for this $2. And the idea is I am investing this amount, 3.4%. I'm investing this amount. This amount accrues 3 years of interest at this interest rate of 3.4%. There's a spot rate for 3 years of 3.4%. And so at the end of 3 years, I'm going to have $2, et cetera, et cetera. So 5 over 1.038 to the fourth. Five over 1.045 to the fifth. That's the 5 year spot rate. And finally, 5 over 1.047 to the sixth. That's the 6 year spot rate. So we get $17.76. Okay. All right, so before I do a more interesting example taken from the Exam FM sample question database, that PDF I showed you before, let's do a very easy example to illustrate using accumulate values with respect to spot rates. So let's find the accumulate value of $10 invested now if it accrues 1, 3, and 5 years of interest. Okay. So to be clear, this means it accrues 1, 3, and 5 years of interest. So I'm going to get 3 different answers corresponding to these 3 time periods. So one thing I want to make clear is that spot rates are for money invested now. Okay, and that was the interpretation of everything in the prior example using present value. Okay, so dealing with the term structure of interest rates for money invested somewhere after right now, we're going to need something called a forward rate for that. And we will do that in the next video. It's a very easy concept, and we're only going to deal with 1 year forward rates because the book only deals with 1 year forward rates, Broverman, Mathematics of Investment and Credit, and I think Exam FM only deals with 1 year forward rates. But anyway, okay, so for this example, I'm not even going to go to the whiteboard. So we have $10 here, and it's being invested only for 1 year. So if I have money locked in for 1 year, we're going to use the annual rate of 2.7. So it's 10 times 1.027. So that's just $10.27. We have $10 invested for 3 years. We're going to get the per year interest rate of 3.4%. So we're going to get that for 3 years. So $10 earns 3 years of interest at 3.4%. That is $11.06. And you get the idea. So $10 invested now, sitting in the account for 5 years, earns 5 years of interest at an annual interest rate of 4.5%. So it's 10 times 1.045 to the fifth, which is $12.46. So yeah, one practical investment that behaves like this is actually a CD, a certificate of deposit. You usually the longer you're willing to lock in your money for a CD, the better interest rate per year you're going to get. And there's a penalty if you do happen to need to take your money out early for a CD, for an emergency, whatever it is. All right, so let's finish off with this example here. So you're given the following information with respect to a bond. The face value is 1,000. So I use par value because this is actually problem 34 and 35. So I'm actually going to sorry. I'm doing this problem right here. I have it written out on the PowerPoint, but this is a problem I'm doing. So it's really the face value. I don't really know why they use par value because you're using it for coupons and you're using it for the redemption at the very end. But anyway, okay. So the face value is 1,000. It's a 3-year bond. You have annual coupons. And the annual coupon rate is 6%. Okay. You're given 1, 2, and 3-year annual spot rates of 7, 8, and 9% respectively. Calculate the price/value of bond. So this problem here uses the term value. It's really the price. Because as I've always said, the price of any annuity is its present value. Nothing different here. Now we're just being a little more sophisticated and using spot rates instead of one single interest rate, one single yield rate rather. All right, so let's do this. Right. So because we are we have different spot rates, there's no quick, easy way to do this in the calculator. It's only 3 years, so you don't really need a quick, easy way to do it. So let's just write the time diagram corresponding to this bond and take the present value, figure out what the price is. So the coupon rate, and I should say RT should not be confused with the bond interest rate. So I won't use R for that. This is 6% annual. So the face value is 1,000. So the coupons is 1,000 times 0.06, which is just 60. Okay. So here's my time diagram, 0, 1, 2, 3. So usual bond, got $60 coupons. Here it's annual coupons. Again, this is otherwise stated. Unless otherwise stated, coupons are every 6 months. This is otherwise stated. It's 60 plus my face value. Okay. 1,060. All right, so we're basically doing exactly like we did in this example here. Because we have the annuity time diagram associated to this bond. So we wrote the annuity time diagram associated to this bond. So we just do the problem exactly like we did before. Okay. And one of the nice things of Exam FM sample problems is they give you a list of multiple choice, because Exam FM is multiple choice. So we're going to check our answer that, we're going to check our answer that it's one of them. Okay. Sorry, 1 second, let's go back. All right, so the present value is, so the 1 year spot rate is 7%. So 60 over 1.07. Again, the idea is we invest this amount for 1 year, we get $60 back. We invest this amount for 2 years, we get $60 back at the end of 2 years. 2 year spot rate is 8%. And the 3 year spot rate is 1060. So we invest this, the 3 year spot rate is 9%. So we invest this 1060 over 1.09 cubed, let it sit for 3 years, we get 1060 back. So basically, we invest this, we're going to get this annuity back. So let's do this. So 60 over 1.07. So I used to do just equals. You don't really need to do that. Just do plus 60 over 1.08 squared plus 1060 over 1.09 to the third, and we get 926. And well, I'm going to use this in a second, so I'm going to write this out to 5 decimal points as usual. All right, so let's see if this is anywhere in multiple choice. Second. And lo and behold, it's B, 926. All right, so that's number 33. The second part of this is exactly the same. the bond is sold at the price equal to its value. That's always what is true unless otherwise stated. So I'm not really sure why they have to remind you of that. So let's calculate the annual effective yield for this bond. So basically we're calculating this yield rate as if this bond was sold at one single yield rate. Okay? So there's two ways to do this. I'll do it both ways. You can either think of this as a cash flow and take the internal rate of return, or you can just do a bond calculation with the calculator. Neither one is quicker than the other, really. I think it's important to understand both of these. So let's do it both ways. Okay, so let's use it. Let's do the cash flow kind of idea. So from this perspective, we shell out 9. I'm not going to write this all out. 9.26 cents. So 60, 10, 60. All right, so cash flow. There we go. So always clear work. All right, so 926.03. I'll even just leave it as rounded to the nearest cent. Life a little easier, though I probably would have saved it. But anyway. All right, so next is 60. And if you'd prefer, you can even just say this is repeated twice. In the past, I haven't done this, but maybe it's better. So 10, 60, enter IRR, cute, and we get 8.918. So let's go see if that's anywhere. 8.98. Actually, I don't think any of that got into the calculator. So let me go back. But entered this here for my initial amount. 60 is my first amount. That's repeated twice. Then 1060, then I went to IRR compute, and that's what it computes. So yeah, lo and behold, 8.9% is here. Okay. All right, so let's do it the other way. So we have a bond. So 3-year bond. Coupons are $60, so that's my payment. We get 1,000 back at the very end. My present value is 926.03 negative. Compute the interest rate according to this for this annuity. Bonds are annuities. And lo and behold, again, 8.918%. So 8.9%. So either way you do it is fine. All right, in the next video, I'll talk about forward rates. Very practical, very useful concept. Something conceptually you really need to understand because there's a basic formula involved, but if you don't really conceptually understand what a forward rate is, I think you're going to be confused. And I have to actually I haven't looked at some of the exam FM sample forward rate problems, but I guarantee you they're gonna try and confuse you because that's what they like to do. If you don't know what you're doing. All right, well, hopefully this was useful. So long, take care. Bye-bye.